Hi. Next our topic is absolute convergence. And in order to check the absolute convergence, we use mainly two tests, ratio test and root test. Ratio test and root test. Okay. And what do you mean by an absolute convergence? Absolute convergence means in this a series sigma an is absolutely convergent if the series sigma mod an is convergent. A series sigma an is absolutely convergent if the series sigma mod an is convergent. Next is we have to find out an example for that. Show that the series is absolutely convergent. In order to show that a series is absolutely convergent, if the series sigma mod n is convergent. When we convert this into a mod an, a sigma mod an, that will become a positive term series. Okay, this is applicable for all type of series, that is the positive and negative, alternating type of series. Okay. Next, we have to show that the series is absolutely convergent. The series is absolutely convergent. This is the series. Okay. How can be done? That is equal to summation mod this one. Modulus of minus 1 power is always 1 by n square, which is equal to summation 1 by n square. We know that this series is converges for all p greater than 1. So this is converges. So the series is absolutely convergent. Okay. What about the next question, that is equal to show that the alternating harmonic series is not absolutely convergent. Find out the absolute value. This is equal to summation 1 by n. Minus 1 power n minus 1 will become positive. So this is, we know that sigma 1 by n is divergent because n increase to 1. When p equal to 1, this is divergent. Okay. So in this one, this series is actually this series is convergent by you. This series is convergent, but alternating harmonic series is not absolutely converges, but it is convergent. Okay, it is not absolutely convergent, but it is convergent. Convergent need not imply absolutely convergent, but we can say that absolutely convergent series implies that will be a convergent series. So this is a very important example for a convergent series which is not absolutely convergent. This is very important. Okay, and this type of series is known as conditionally convergent series. Conditionally convergent series. Okay, this is the definition of conditionally convergent series. Series sigma an is conditionally convergent if it is convergent but not absolutely convergent. A series sigma an is conditionally convergent if it is convergent but not absolutely convergent. Okay, is it clear? It is convergent but not absolutely convergent. Next theorem, we have already told that if a series sigma n is absolutely convergent, then we can see that that series is convergent. The proof is here. Using the absolute value property, minus mod an less than or equal to an less than or equal to mod an. Adding mod an to both sides of this inequality implies 0 less than or equal to an plus mod an less than or equal to 2 into mod an. Then bn equal to an plus mod an. Then the last inequality becomes 0 less than or equal to bn less than or equal to 2 into mod 2 mod an. If sigma an is absolutely convergent, then sigma mod an is convergent. If sigma an is absolutely convergent, then sigma mod an is convergent, which implies that sigma 2 into mod an is convergent. Sigma 2 into mod an is convergent. Therefore, sigma by using the comparison test, sigma bn is convergent. By comparison test, we can say that sigma bn is convergent. Okay, so we have an is equal to bn minus an equal to bn minus mod an, then sigma an equal to sigma bn minus sigma mod an, which is convergent by using the theorem. Because sigma bn convergent, sigma mod an is convergent, so this series sigma an is convergent. This is a result of this. Okay, so absolutely convergent series implies it is convergent, right? Next, we have to next example. Determine whether the series sigma n equal to 1 to infinity sine 2n divided by n square equal to sine 2 plus sine 4 by 2 square plus sine 6 by 3 square plus etc. This is converges or diverges. That is, we have to determine. Okay. Consider summation mod sine 2n divided by n square. Okay, we know that sine 2n is always, sine x is always, modulus sine x is always less than or equal to 1. Because sine x is always, the value of sine x lies in between minus 1 and 1. So, mod sine 2n is always less than or equal to 1 for all n. Then we can say that mod sine 2n divided by n square is less than or equal to 1 divided by n square. Okay, so summation 1 by n square is convergent P series. Right, this is convergent series because 1 by n raised to p, where p is equal to 2, which is strictly greater than 1. So this is a convergent p series. So by using this one comparison test, we can say that mod sine 2n divided by n square is convergent. Mod n square is same as n square, so no need to put this absolute sign. Right? This implies that summation sine 2n divided by n square is convergent. Okay, I think it's clear. Okay. Next, we have to study about what you mean by ratio test and at which time we have to use this ratio test and root test for the testing of the convergence. Okay, this is a ratio test. Sigma, let sigma a and b a series with non-zero terms. If limit n tends to infinity, mod an plus 1 divided by an equal to L, which is strictly less than 1, then sigma an converges absolutely. Sigma an converges absolutely. If it is less than 1, sigma an converges absolutely. And the next condition is if it is greater than 1 or it is equal to infinity, then we can say that sigma an is divergent. If it is equal to 1, this test is inconclusive. That means we have to apply another test for that. Right? If it is less than 1, sigma n converges absolutely. If it is greater than 1, if it is diverges. Right? This is a proof here. Suppose that limit n tends to infinity, mod an plus 1 divided by an equal to L, which is strictly less than 1. Let R be any number such that 0 less than or equal to L, strictly less than R, strictly less than 1. Then there exists a number capital N such that mod an plus 1 divided by an is strictly less than r whenever n is greater than or equal to n. Equivalently, this mod an convert this into go to RHS, then r into mod n. This will become for n greater than or equal to n. Letting n take the values capital N plus 1, N plus 2 successively. And mod an plus this will become above. This one will become a mod n plus 1 less than mod n r n plus 3 less than mod n plus 2 r mod n. In general, mod an plus k strictly less than mod an into r raised to k for all k greater than or equal to 1. So the series sigma k equal to 1 to infinity mod an into r raised to k equal to mod an into r plus mod an into r square plus mod an into r cube plus etc. Which is convergent geometric series with a 0 less than r less than. Listen this series. This is a perform a convergent series, geometric series, and this series converges if this radius of convergence, its radius of convergence is less than 1. Then we have the each term of the series sigma k equal to 1 to infinity mod an plus k equal to mod an plus 1 plus etc. is less than the corresponding term of the geometric series. This is convergent actually. And this is an plus k is strictly less than mod an plus 3 strictly less than mod an plus 2 and so on. Then we will get what will happen by using sigma comparison test, then implies the series 2 is convergent. How can you say that 2 is comparison test imply the 2 is convergent? How can we say that this is equal to this is a series? Okay, sigma mod an raised to k is convergent, so we can say that sigma mod an plus k series is convergent. That means sigma mod an is also convergent. ഇതിൽ സിഗ്മ മോഡ് എ എൻ പ്ലസ് കെ ഈ സീരീസിൽ വണ്ണിന് തൊട്ട് മുന്നേയുള്ള ഈ കണ്ടീഷൻ എടുക്കുക, ഇവിടെ കമ്പാരിസൺ ടെസ്റ്റ് അപ്ലൈ ചെയ്യുക. ഇവിടെ സിഗ്മ മോഡ് എ എൻ ആർ റേസ് ടു കെ എന്ന് പറയുന്നത് ജോമെട്രിക് ദിസ് ഇസ് എ കൺവെർജന്റ് ജോമെട്രിക് സീരീസ് വിത്ത് 0 ലെസ് ദാൻ ആർ ലെസ് ദാൻ 1, റൈറ്റ്? ബൈ യൂസിങ് ദിസ് വൺ വി ക്യാൻ സീ ദാറ്റ് ഇങ്ങനെ അവിടെ കിട്ടിയേ ദിസ് ഇസ് ഈക്വൽ ടു ആറ്, ഇങ്ങനെയാണ് ആറ് ചൂസ് ചെയ്തത്, റൈറ്റ്? So the use that we can say that first condition is okay. Suppose limit an plus 1 divided by an is equal to L, which is greater than 1. R is a number which is greater than 1. What will happen? This term is greater than R, which is greater than 1. For every n greater than or equal to n. And what will happen? Mod an plus 1 greater than mod an. Thus limit n tends to infinity an not equal to 0. So sigma n is divergent by divergent test. What will we see? This test is inconclusive because consider the series sigma mod sigma 1 by n sigma 1 by n square. For the first term of the series, for the first series, this is equal to 1. And this, for the second series also this is equal to 1. But we can say that for the first series is divergent, second series is convergent. So we cannot say that if the limit is equal